In this video, I'm going to solve this question. To obtain information on the corrosion resistance properties of a certain type of steel conduit, 45 specimens are buried in soil for a 2-year period. The maximum penetration for each specimen is then measured, yielding a sample average penetration of 52.7 and a sample standard deviation of 4.8. And then the conduits were manufactured with the specification that true average penetration be at most 50. They will be used unless it can be demonstrated conclusively that the specification has not been met. What would you conclude? So now, first of all, let's write the information that is given in the question. So we are given that n is equal to 45. So n is equal to 45. And the sample average is 52.7. So we are given that x bar, which is the sample average, is 52.7, and the sample standard deviation, that is s, is equal to 4.8. So this is the information that is given in the question. And now let's talk about the claim that has been made in the question. So the claim is that the true average penetration be at most 50. Let's denote the true average penetration by mu. So the claim that is given in the question is that mu is less than equal to 50. So the counter claim to this would be mu greater than 50. Now, because this is the claim with the equal to sign, so this is our null hypothesis. So this is the null hypothesis, and consequently this claim is the alternate hypothesis. So our null hypothesis is that the average penetration is at most 50, and the alternate hypothesis is that the average penetration is more than 50. Note that in this case, we are not given the population standard deviation. We have sample standard deviation, which is 4.8, but the n is sufficiently large. It is greater than 30. In our case, n is equal to 45. So that means we can use Z test in this case. So we can work with Z statistic. Now let's draw the rejection region. So as you can see in the alternate hypothesis, we have a greater than sign. So that means this is a case of right-tailed test. So right-tailed test. Now let's draw the rejection region. So say this is how the Z distribution looks like. And as we are not given any specific value of alpha in the equation, let us assume that alpha is equal to 0.05. So because this is a case of right-tailed test, so we will have rejection region here. So we can say that this is the rejection region, and here alpha is equal to 0.05. And the value of Z here is called Z critical. So this is the critical value of Z. We can find the value of Z critical by looking at the Z table. Basically, we have to find that value of Z such that the area to the right of that value is 5%. So I'm writing the direct answer here. So once you see the table, you will find that this Z value is 1.645. So the Z critical value is 1.645. Now let us find the Z calculated value. So now let's find Z calculated, and then we will compare Z calculated and Z critical to see whether we reject the null hypothesis or we do not reject the null hypothesis. Well, Z calculated is equal to x bar minus mu divided by sample standard deviation divided by under root of n. And note that this mu that I have written here is the value of mu under the null hypothesis. In this case, we are given that x bar is 52.7 and the value of mu under the null hypothesis is 50. So this is minus 50. The sample standard deviation is 4.8 and n is 45. And solving this, we get 3.77. So the Z calculated is equal to 3.77. Now our Z critical value is 1.645 and Z calculated is to the right of this Z critical value. It will lie somewhere here, 3.77. So that means the observed value of the Z statistic lie in the rejection region. And this is because the Z calculated is greater than Z critical. So in this case, we should reject the null hypothesis. So the conclusion is that we should reject the null hypothesis at 5% significance level. So we can conclude that there is sufficient evidence to support that the average penetration is more than 50. And that's it. This is all for this question.